So I wanted to give you some help with urban microclimates. So here what we're talking about is urban stress. So if we take a systems approach, when you build an urban environment, you are going to change the system. So we're going to dig down into our knowledge, which is actually quite good. Our knowledge is quite good about a systems approach and how the environment is, how the weather and climate is affected by urban environments. So once we've got that knowledge, we can apply that knowledge to managing our urban environments and trying to reduce some of the negative effects of living in urban environments. So what we're going to do is going to start off with looking at a little bit of the theory, and we're going to start looking at the concept of an urban heat island. And as we look at the concept of an urban heat island, various things will crop up and appear. And in later videos, we'll go through those individual things in more detail. So as I said before, that this whole process of an urban heat island is actually quite well understood. So in this diagram, you can see that here we've got a prevailing wind. And this prevailing wind is blowing across this hypothetical urban environment. So those rough urban surfaces actually slow down the wind. So there are cases in urban environments where we actually have lower wind speeds, and that's simply because the surface with all of the buildings is a lot rougher, so the friction slows it down. Now that has implications for things like keeping the city cool, and it also has implications for removing pollutants, particularly at street level, that inevitably urban life generates. In addition to that, so there we would say that we would expect slightly higher temperatures because you get less airflow around the city. So looking at another part of the system as well, and we can see here, in this statement here, that we've got additional heat from rooftops, buildings themselves, transportation, industrial activities. They also produce a substantial amount of heat. All that heating rooms and air conditioning, that also heats the external environment. So in general, what we tend to find is because of that decreased airflow and because of the heat that is being generated by human activities in urban environments, in general, urban environments tend to be 2 or 3 degrees warmer than their surrounding rural areas. So here we've got two things here. They call it anthropogenic. That's humans releasing heat into the atmosphere. And the other thing, which is indicated by these arrows as well, is that rooftops of buildings can heat up very, very quickly, particularly if those buildings are a dark colour. So the other thing that we're going to talk about is the albedo. That's the reflectivity of the surface. And if it's a dark surface, it has a tendency to absorb that solar radiation. So again, during the day, those buildings will heat up very, very quickly because of the dark colour. Now, as we know these things, what we can do is we can start thinking about the design of our urban environments to reduce that anthropogenic heat release, to reduce the effect of albedo. It might on the buildings, it might mean making the buildings a different colour, and actually thinking about positioning our buildings to encourage or facilitate or allow that natural wind to blow through. So we're going to go on to think about a systems approach and how we can apply these basic ideas. So you see this image here talks about a mesoscale. A mesoscale is a medium scale. For us, it's at the scale of a whole city. But also, the next video is going to go on to talk about the microscale, which is at the individual street level. So this video has thought about a systems approach. It's introduced you very briefly to the concept of an urban heat island, and that urban heat island occurs because the urban environment has modified the system, and this is a mesoscale system. The next video will look at microscale systems and microclimates in urban areas.